All right, App School, lesson 3 out of 8 total. So, if we're counting from 0, then we are coming up on halfway through. Now, contextually, there's a sense in which last time with, seeing in particular delta and delta follower, which we'll revisit in a moment here, you've seen what you need to see as an app developer, right? This is the actual content that you want. Like, how do you produce an application on Arbit? What does that mean, right? It's that you have this Gall agent that has a certain shape, it has a certain behavior, it has a certain performance, and you are implementing over the top of that. Now, there's a lot of nuances. There are different design patterns that people have implemented and put together that allow you to do this more effectively. We've seen some of the other tooling like structure files and mark files that get invoked as well. And so what I'd like to start us off with today is walking back through delta and delta follower, which you saw for the first time at the end of the last lesson, and spending some time talking about what's going on with those. And then I've also started creating a neck, which would be after Zod, neck is the next galaxy, and we'll have 2 galaxies, and we can play with a follower on one or poking from one to the other, based on some of the questions that people had as we started to play with it last week. As part of your homework, I also had you look at the To-Do app in which is in the regular documentation. And I'd like to look at some features of that as well as we proceed here. Nominally, our topic is passing data. And so we need to talk about the data request patterns, how data actually get passed between agents, and what it looks like for an Urbit app to talk to something else like a front end, something else that isn't Urbit. JSON is a data format that's commonly used in front end and client server software development, things that use the browser typically. And so a lot of Urbit tooling has been built to facilitate that. So we'll take a look at that as well today. So to start us off, delta.hoon was the agent that we introduced last time. And if we're looking through most of the boilerplate here, it doesn't look that different from something like Charlie. It's not doing a whole lot of other kinds of things. What it is going to be doing differently is it will be handling, let's see is this too small? If I'm this small, what I like about this small is that it fits everything in one line across my screen, but I can zoom back in if that's preferred.
It's possible to zoom in on the client side and follow the cursor. It works pretty well.
So what do you mean on the client side? On
the Zoom client side, if you go to view
and
options, I can set it to 150% and follow your cursor, or 100%. And then
okay.
Yeah.
Okay, that works. So I'm going to leave it like this then, because then we actually get these lines all the way across, and it's much easier to read cards that don't wrap than when they wrap. All right, let's see. What's different with Delta? It handles, okay, on init does nothing special, on load does nothing special. So we have on poke handling push and pop. This is something that Charlie did for us as well. So we can push a value, we can pop a value. On peak does nothing different from what we saw previously. What is different, and you'll recall that I have been changing this everywhere to list card cab this, just to make that a little bit easier to read as you come into this for the first time, is that this will, if you subscribe to Delta, then it will return to you an update mark, an update style value that has the head tag in it, and then the list of values that is actually in your current state. That's all we've added with delta.hoon. In Delta follower, this received an on poke. And notably, we did this as a noun rather than creating a Delta follower action or something like that. We could have done that, right? We could have introduced, there's a particular mark type. Noun is the most generic mark, so everything can be backcast to noun, but you lose type information by doing that. And so the way that we've handled that here, we are asserting with a whatgar that what we're receiving is a noun. The type of the mark is inside of noun. And then we are doing basically a cast from the type, the value that we're actually receiving in the vase to either a head tagged sub of a pat p or a head tagged unsub of a pat p. And in practice, what that looked like, let's see, .zod.run. Actually, I have another window running Zod, so I need to close that before I can do this. All right, so for Delta follower, it looked like this piece at the bottom here. Col Delta follower, Pam noun, and then a cell of sub and Zod. And then every time that I would push this, I would also receive this value would come back in on agent. So delta dot. So let's walk through the whole life cycle again, because you saw it for the first time last time. I have delta dot hoon running as an agent. I have delta follower running as an agent. When delta follower receives a command, col delta follower send sub sig Zod, like this. This comes in the on poke arm. It comes in as a noun. I don't actually need this assertion here. I could ignore this assertion. You know, I could turn this off and then it wouldn't assert that it's a noun, but I am making that assertion just for a little bit of type hygiene here. We are telling it that it is either a sub or an unsub. If it is a sub, then we make no changes to this. We don't make any updates to our state, because delta follower has no state. If you look at it, there is no state definition. There's no state that's being carried here. Delta follower is simply going to print the values that it receives. It's not going to store its own copy. It could, you know, we could write an agent that did that, but this agent doesn't do that. It just is going to print out the values that it receives. And what it will do then is it'll pass out a list of cards, and there's one card in our list, and this card is going to be pass along with a label named values wire to an agent on the ship, which is the value P in our action. This notation here, tis pat P, is equivalent to P tis pat P, names it by the same value there, the same way that this creates a vase named vase, and this creates a mark named mark. It's going to pass it to the delta agent on that ship. It's going to pass it a watch card, and it's requesting to watch everything called values. So it's simply saying, I would like to watch everything called values. And whenever something changes that you need to pass back to me with that label values, in this, you can think of it as like a channel, like I'm watching the values channel. So anytime a message comes back to me along that, please tag it with this name values wire so that I know which thing it corresponds to when I receive it. This is how I'm going to keep track of if I've made multiple requests for different bits of data, whatever's going on. In this case, I'm only requesting one thing, so I don't have to worry about these being unique. And in fact, it complained down here when I subscribed twice. It said watch not unique. Subscribe wire not unique. That's what it's complaining about, is I'm not giving this a unique name every time I ask it to label information. So this watch card goes to Delta. So this was initiated in our on poke arm. This watch card goes to Delta and comes in the on watch value here, the on watch arm here. All right. And we're asserting that the path that we can watch, in a sense, the only channel we're sponsoring is values. So it must match values. If you try to subscribe to something else, it will crash here. Let's actually try that. We'll see what that would look like. Actually, I would have to update Delta follower and change this value here to make that happen. Maybe we'll come back and do that in a minute. So this watch card comes in, it's handled in on watch, and I'm going to return a value by giving a gift back. There are different kinds of gifts that can be passed back. For instance, a watch ack, which is basically saying, yes, you successfully subscribed to me. Here I'm giving back a fact, which is a single piece of data. So a single datum is heading back. And I'm going to pass it with the delta update mark. And then I'm actually going to pass it with, typecast to the value of init values, and then my whole list of information here. And then anytime I make a change, when I receive a push or a pop, I'm going to tell all of the subscribers along the path values or the channel values about that change. Like, what is the thing that changed in those cases for me? Did I push a value? Did I pop a value? Did I add a value? Did I delete a value? Either one of those cases. When this gift comes back, it will come back in the on agent arm. All right, so it's going to come back in this arm here. Coming down the on agent arm, we can see that it must come back along the values wire, which is the only label that we had for it. So we're just asserting it's kind of a sanity check. It doesn't do anything else for us, but it's a little bit of a sanity check. And then we're going to switch on the head of that result. In this case, it calls it a sign, but basically we're getting a value back. We're going to switch on that. It's either a watch ack, a kick, a fact, or something else, in which case it goes to on agent default wire sign. A watch ack posts a notice that says, I successfully succeeded in subscribing to you, unless it has content in it, in which case it failed. So it'll send you a watch acknowledgement, either with a sig saying, a null, an empty value saying, yes, you succeeded, or if it passes back a unit with a value in it, that value is an error message. It's telling you something went wrong. Maybe you didn't have permissions to read this. Maybe the wire or the path that you were trying to use is invalid for some reason. You can't subscribe to this. So you'll get that back in those cases. A kick occurs when someone is canceling from the other end. So I may decide I want to reset all of my subscribers. I want to reset all of my followers, set them back to 0. I would send everyone a kick, and it would tell them to drop it. By convention, because kicks can happen in various circumstances, by convention, we attempt to resubscribe once, and then we fail. So we can also pass the same card back, attempting to subscribe again, and then if that fails, then it'll drop out. A lot of the boilerplate of watch ack and some of the other things like kick is handled by Gall. And so you won't need to explicitly handle these things in many cases. Like you need to handle, but it's boilerplate like this. It's just, did I succeed? Print a message. Fact is our interesting case. Fact is the case that we've gotten something from our subscriber. So here we're going to print the fact plus the sign. So if I push a value here, I get two things back printed. So the first is the fact, and then the kind of thing I got back, which is a delta update. This syntax here, since I'm still trying to clean up syntax is equivalent to this. It's head tagging some quantity with a label. And then I'm printing what the actual update contents is. In this case, it's a push, target is Zod, value is 300, and I can see exactly what those are. I can confirm what my current contents is by doing delta aceless debug to spit those values back out to me. And then in this case, because I'm not storing any information locally, I just keep the thing. Now, if I wanted to make a couple of changes to Delta Follower, let's suppose that I want to change Delta Follower so that it does keep track of some value, some quantity. It keeps track of, keeps its own copy of the values that it's received. What would I need to change to make that happen in Delta Follower? Okay, so I need some kind of state in Delta Follower. For simplicity, let's copy this state definition here. I guess maybe through there. So this would be basically replacing here. We're aliasing card, but we don't define a state. All right. Now I don't have to name this the same thing. Any of this, none of this has to be named the same thing. I can name it a head tag like this. So let me actually call it something different. And then I can call this numbers and keep track of these values like this. So I can change other things. With Bravo Charlie Delta, we've kept everything the same. So let's start to move things around and change them a little bit. We probably need to do something with on init, because we did change that behavior. So let's see, Delta Follower does define a this and a default. So we don't need to change either of those. There's an on init down here. It doesn't do anything right now. Neither does Delta. So unless we want to do something special with the state, I don't think there's anything to do with on init. On save would be, I guess, just in vase. Yeah, so this would just be a vase of whatever the current state is. On load, we'll need some content now. And we'll need to change this to whatever name that we're actually calling on load. In this case, since we're not making any changes, we don't have any pre-existing states, so we don't have to worry about a state transition from a pre-existing version of this agent. Okay. Now, I actually want to, every time I receive a number, I want to add it to my current list of numbers. How do I do that? Where do I do that, and how do I do that when I receive a number? If we go back to Delta, when I am in on poke and I push a number, how do I change my local state? Okay, so I've got two differences of opinions on poke and on agent. And the answer is, it depends on how I'm getting the information. So anywhere that I have something that returns a list card cab this, anywhere that I have something that returns that, I can change my state. This is actually what I'm doing right here, for instance, right? I'm saying replace my state with my old state. In this case, this ends up being a operation on self. It's not doing anything because it doesn't change it here. Delta follower will receive a sub and an unsub, but sub and unsub don't change numbers. So in this case, we don't want to handle it in on-poke, but in Delta, we did handle it in on-poke. Here, we don't have any changes we need to make to this because we're not receiving a value with subscribing or unsubscribing to someone else's agent. But in on-agent, when we receive a fact, we are. At that point, we are receiving a change. And so we call this numbers here. And then the value that we're getting, let's see, we're getting a Q cage sign back. So we actually want to, let's just call this result. And so this is our actual value that we're doing it, that we're getting from it. And then I want the value inside of results here. Now there's actually a problem that we're going to run into here from a type perspective in Hoon. Let me see if this will compile. Oh, we have neck up, so we'll be able to experiment with neck in a moment. Let's see, Delta follower. Okay, I am actually running inside of Zod. So if I bar commit Delta, this should fail to compile. And I know why. 6422. All right. So when I receive a fact, let's look at these lines 60 through 64, because this is where our trouble are. Oh, and the comment in the chat, you could change the state on any arm according to your intention in the app, right? You can change it on any arm that returns something that modifies your state. So namely, it has to return something that has cab this. Yeah, and so I guess you could do it in any state, in any arm, but conventionally you would not do it in some arms. Like your save arm would not be a good place to change your state, for instance. I guess you could be doing something weird like counting the number of times you've saved. Normally, but yes, so you could, in practice, you'll probably change it in on poke, on watch, on leave, which means someone dropped a subscription, on load and on init will change state. Those are, and on Arvo may change state. If I get something back from Arvo, I probably would not change it in the other cases. Like if someone's peeking at me, I guess unless I'm tracking the number of times someone has requested information, I'm not going to change my state, because a peek is a scry is a read only request for information. All right. Oh. Let's see. So I am receiving a fact. I am asserting that my fact is a Delta update. I'm printing that fact. I am unwrapping that update as a value result. And so what is the type of result on line 63? Like what is that? Got a guess for me? What is Zapgal asserting? Zapgal is saying, I have received some value, some noun, and I am coercing it to be this type, which is an update type, which is the update that comes from the structure file. So there's a Delta structure file that defined an update type right here. And this update type can be, and actually it would be equivalent. I'm including it as a super type there, but it's equivalent to saying this. So it can be an init, a push, or a pop. So at this point, I know that result is an update. I could state it this way as well to be explicit about the type. So when I refer to value.result, do I know if result has a field named value? Look at my structure update here. Do I know if an update has a field named value? Okay, how do I know? What if I get back a pop? If I receive a pop, then it doesn't have that value. It has a field named target, but it doesn't have a field named value. If I receive an init, it does not have a field named value. It has values, but not value. So when you get something like this, a find fork, and it tells you it's looking for something, what that means is that from Hoon's perspective, you haven't narrowed things down enough yet. So this is a union, right? Like we can say this is either an init, or it is a push, or it is a pop. It's one of these three things. Only in one of those cases does a value.result exist. And so we actually need to switch on result. And we know that we're either going to get, let's switch on head.result. So if it's an init, then we need to return an empty list. And we should be able to just replace our current list with the list we received. We happy with that? We can do that. Nothing really breaks if we do that. Maybe we wanted to keep track of all the information, in which case we would weld numbers to values.result, but it's fine. We can do it this way. If it is a push, then we should be able to receive a value like that. And if it is a pop, then we want to receive the tail of numbers that we're knocking off our first value here. I will show you a couple ways of resolving this. This first one's going to fail for the same reason that the other one failed, but it's going to fail on line 72. It's going to fail there first because I didn't terminate my what happened, my switch statement. Okay, now it's going to fail on line 72. All right. Find t.numbers, find fork. So what's gone wrong here? What's my problem here? I'm asking for the tail of my list of numbers. I'm chopping off the head. I'm getting rid of the head. I'm taking the rest of my case. So it could be the case to the Hoon type checker that this is an empty list, and an empty list has no tail. So we've run into a case where Hoon is saying, I don't know that this value is guaranteed to exist at runtime. This is something that's a little bit hard to get used to in working with Hoon. There are two ways around it. One way is to use a whatsig on numbers and behave differently. So if someone tries to pop where there's nothing there, then I should just return this and make no change to numbers and things will be happy. So this should work. Yeah, so it liked that. It was fine with that. This is one way to solve this problem. Is I'm making this assertion that either it is empty, in which case I don't do anything, or it is not empty, in which case a tail exists. Let's see. We've got some sort of nesting problem. Oh, because there was no previous state. So I may have to deal with a state transition, or I can bar nuke it in a minute. Let me actually just bar nuke it right now. Which has no state, so it's not going to be a big deal. So now let me rain delta Pam delta follower and turn it back on. All right, so now I can tell it to subscribe to Zod, and it tells me the values that it received from Zod. So now if I delta follower plus debug, it should tell me that it has an internal state. Oh, no, interesting. You know what? Actually, I bet it failed on the. It failed to build, so it failed to actually reload. That's why. Okay, we'll solve this in a minute. All right, so one solution to this problem is to make this assertion. The other one is there's a function called slag, which would take all the values past a certain point in a list. And if you do this, then this just operates on a known list. And so if I slag on a list past the end of the list, I just get a null value back, and it solves the same problem for me. All right, let me rain and turn this back on. And let me sub. Okay, I got those values. Let me check my state. Yep, so now I have an internal state that is zeros. It has a list of numbers, and then there's things it knows about these numbers here inside of it. Although actually, why is it carrying this this value here? What is this value? Oh, sorry, it's printing out a vase of the type. That's why. And so the head of this is 0, and the tail of it is the rest of the numbers that are present in the state. Okay, that's why it looks that way. All right, that's fine. That's all good. So we can use slag, or we can use the other solution to do this. And then we can subscribe back and forth between Neck and Zod and play around with things going back and forth. All right. So those are all things we can do. Those are all options we have as we are trying to solve these kinds of type problems that you're going to run into. The disadvantage of this is that sometimes getting code to compile is fairly frustrating because you're having to deal with what feels like they might be edge cases, like, is my list an empty list? The benefit of this is that by the time you can get Hoon code to compile correctly, you've actually already solved entire categories of errors that in a dynamically typed language like Python, you might run into much later in your development process. So, you know, there is a lot of payoff for having this sort of strongly typed enforcement at compile time as well. Now, if we go look at some of the other things that are out there, this is the structure file. So let's look at, so we'll look at structure and mark files now. This is the structure file for to do. And so from your homework from last week, part of your homework is to complete the To-Do app tutorial in the docs. And this will have you set up, in this case, it'll have an action and an update, and it'll have several aliases for other values. This is an extremely common pattern in Hoon, where we are going to create particular instances that are aliases for existing types. So when I did this with Delta, I didn't call these anything special. They were PAT-Ps. If I were following a pattern that is commonly used, I might say something like this, ship is PAT-P, and then everywhere that I'm using PAT-P now, I would say ship. And this gives you a little bit more control over the way things that are being represented, and what the intent was of including that value there. And so a task then is a cell pairing a name, which is a PAT-T, a chord, with a true-false value of done. So for each task, is the task done? There's a name of the task and whether or not the task is done. And then the list of tasks is a map from an ID, which is some kind of generated number, to a task, which is a name and whether or not it's done. Then you have a whole bunch of actions, and updates are identical to actions, except that it also has an initial task, an initial message, and this is what's sent the first time you subscribe. So this is the same design pattern that we saw with Delta and Delta Follower. When someone subscribes for the first time, we send them all of the state we currently have. So watch for that pattern in Urbit Agents. If you're subscribing to someone else, then you're going to be asking for what is their current state when you synchronize with them for the first time. There's also a mark that looks like this for to-do. This is the action.hoon. Most marks are fairly simple because they delegate a lot of their validation role to the molds. And so in this case, it's a door that receives in its sample an action to-do named action. If you're going to convert, so a grab handles this conversion to our type, and a grow is conversion from our type. So this one can only convert from a noun, and it does that by passing it through the type action to do. Right, it does that by taking whatever it has and then basically asserting that action as a mold from what we saw previously. So this is basically apply a mold. If we're converting from our type, then what we're going to do is we're going to hand out the current action. You notice this is the name. So another way I could write this is I could write it like act, like that. Act, tis, action, cold to do, and you make sure you distinguish these two. I'm actually handing the value itself back via the noun arm, and then that's going to come in some other marks noun, which will then apply mold to it. Most of the time, something like this is sufficient. It solves the basic problem that we have in converting data to and from regular nouns. Anything that is sufficiently Urbit native that it only speaks nouns will only need this kind of mark file, the ability to convert to our type from a noun and the ability to convert from our type to a noun. There are other kinds of interfaces that we will occasionally want to talk to, such as JSON files. So a JSON is some kind of a data format that it's a JavaScript object notation. It's used in a lot of languages besides JavaScript, although that's what it originally came from. For instance, Python is designed so that JavaScript objects are just part of Python. I could drop this straight into Python and this would be regular Python code, the same way that JavaScript sort of like natively knows how to do this. So it's a very low overhead representation, like XML or YAML or other things that are out there. It's just designed to be a generic interchange format. So here we have what we call it, a map or a dictionary or an associative array of value labels to corresponding values. So these in this case, these are color names and HTML hex codes for those particular colors. Hoon is going to internally represent JSON values, not as plain text strings, but as structured data. So if I were taking what I have here and representing it in Hoon, let me actually do it without Hoon, why are you doing that? There we go. Okay. So for Hoon, I don't know why it's showing me weird. Oh, it's showing me spaces because it's trying to treat everything as a JSON. Let me go back to plain text here. Okay. Hoon is going to treat this as a set of structured data. This is the Hoon native representation of the same data structure. And so you'll see that every string actually corresponds to a chord, which is the ptiz on the right-hand side here, but it's head tagged with sen-s as a string. And then it has a label, which in this case is light blue. And then the whole array of values is head tagged with O for the object array or whatever JSON calls it natively. This is not, it's not uncommon. This might shock you a little bit because it looks like, why did we make this transformation? It's not uncommon for languages to have their own sort of native representation. So you may have a data language like HTML or XML that, Hoon would convert this to Sail, Clojure would convert it to Hiccup. Other languages might have their own internal representation of these. But what this is it's a noun that retains all the information that's in the JSON object, but makes sure that it is able to be processed as a Hoon native type. At the highest level, line 26 here, what does line 26 imply to us?
Unit.
Yeah, unit. List would put the sig at the end, right? It would put the null at the end. It'd be null terminated. Null leading implies to us that it's a unit, which basically means that either anytime we process a JSON, it's going to return a unit, because if it crashes trying to process the JSON, then we just get back null. Otherwise, it succeeded and it successfully parsed all of this and turned into whatever thing it has here. So we should be able to take some value like let's see if I have it. Okay, yeah, I've got some JSON values here. All right, so here's a JSON. This is kind of a more complicated one because it's highly nested. It has all sorts of kinds of things in it. So what I can do in Urbit terms is I can call it some values. I'll call this example, and I'll put all of that junk in a single quotes. All right, so I have this string named example. Let me paste that to you there in the chat. And what I'm going to be able to do is process this into Hoon. And if they haven't moved things around too much, they made a change in the most recent. Yeah, that one works. And so I better update the notes to actually be correct. They renamed one of the arms and deprecated. It used to be D hyphen JSON, and now it's a D arm inside of a JSON arm inside of HTML. So D col JSON col HTML example will unpack that whole thing that I just had. So you can scroll up and you can see, first of all, it returns a unit like we expected. It successfully parsed it into JSON. If it had failed anywhere, that wouldn't have existed. And you can see anywhere there's an O, that means it's a list of key value pairs. It's a map or a dictionary. Anywhere there's a string, it's going to have like a sen s. Yeah, okay, so this failed for someone. Toptal, what did you see when it failed?
Find JSON there. Yeah, find that JSON.
Did you do JSON col HTML?
Yeah. That's the thing Daniel got. I wonder if I'm or something.
And you named it example.
Yeah.
You might be using an old fake Zod, in which case this would be the correct way to stay it. Try doing this dhep JSON col HTML, which is a dJSON arm inside of HTML.
No, that was for me. I don't want to derail anything, but
Okay.
I thought that's interesting. I'll figure it out.
Yeah, so this happens because they've changed the interface in the most recent update of everything. And so officially this interface is deprecating. I think it's still supported in this version. So I should be able to run this, and yeah, I can run it and have it work. But this is what they want everyone to move to. The trend, it used to be that anytime you would process information, you would have like an NXML and a DXML, and you'd have like all these arms that are named these things. Now the pattern is you'll have a core name something, and you'll have an N arm and a D arm to convert to and from inside of that core. So this is an update in the way that they've decided to organize these converters. Is it better? Is it worse? I don't know. I mean, it takes up the same number of keystrokes, so it's probably a slightly cleaner design pattern, because then we can implement this interface inside of things. So that's what was going on there. Let's see. I was going to say, so there's a lot of sen s's that refer to particular strings that are going on here. Let me see if I can find. That one only has strings. Let me do another example here. All right. So there's an example that I pasted there, which is this JSON. So I'm going to dJSON HTML this long thing. This one has a first name, John, a last name, Smith, is alive, true, age 27, blah, blah, blah. Right? It has more kinds of things in it. What I'd like to look at here is, so some numbers, like phone numbers, this is still a string. It's head tagged with sen s. Okay, so there's, it's still, it's a number, but it's text, right? It's a number as text. The same is true for the zip code here. Where's age? I'm looking for age. Okay, here's age. What is the number in age? How is this handled? So what is sig.27? What kind of thing is that? What's the type of sig.27? Yeah, so it's head tagged with sen n. What kind of thing is sig.27? Floating point's a good guess, but floating point is dot sig, which is very similar and confusing. Unfortunately, because they decided to use a really restricted subset of ASCII to define valid atoms, we end up with a lot of syntaxes that are close to each other. All right. So how do I find out the type of something if I don't know the type? Remember Zapgar? Yeah. So I can do the whole types where I can take the head of Zapgar, and that'll give me the type. Okay, so it's a pat TA. It's a not. So this is actually text. So what we have here is our number is a cell that's head tagged with N for number and has a text value of 27. So we're actually storing our number as text. Why might we be doing this? It's kind of an unusual thing to do because JSON, it's a very load-bearing value there. Yeah, functionally what it comes down to is, yes, you're receiving the value as text because JSON is text, right? But it's also that when you receive a number in JSON, a number that comes from JavaScript, a number that comes from whatever else, that numbers scheme, like the way that it thinks about number, doesn't directly map to Hoon's number system. Right. So if I get some number, is it a signed number? Is it an unsigned number? Right. So like, a regular unsigned numbers like a pat UD, a pat UX. These are unsigned numbers. But if I need to keep track of what it is, I might want this to be a pat SB or a pat SD or something. These are signed numbers. And so when I process this from text into Hoon, I'm actually going to have to specify how do I want to handle the possibility this is a signed number, or maybe it's a number with a fractional part, right? Like a floating point number. Maybe I actually want to load this as 27.0. Maybe I want to load this as positive 27. Maybe I just want to load this as 27. Maybe I want to treat it as like a date, right? There's actually a lot of different ways that you do this. And so right now we've just said, Hoon has said, it is a JSON number, and I have made zero judgments about what that means, what to do with it. Is alive was marked as a true, and so here it's a Boolean, it's a send B with a value of yes for true. So it's that one is also marked, but it's a little more straightforward because it can only just be true or false. It can actually resolve it to a Hoon value of send.n or send.y. So what we're going to do when we work with JSON is we're going to have to do everything twice. When we build JSON, first we parse JSON to Hoon's JSON type, and then we're going to reparse the JSON to particular values, the things that we actually want in our program. So it's always going to take 2 steps to do this. So the first one's easy because the first one is just JSON HTML. The second one is a custom reparser that you're going to have to write. And that's why I'm introducing it here, because it's kind of a weird language that you end up having to apply to things to make this work correctly. So if I were to give, let me give you a shorter one because that long one's probably not going to work. Let me give you, oh, you're not pasting for me. Come on. There we go. I don't know why the paste won't work from the text I gave you. You can type it if you don't type too many. All right, so I'm doing a simple JSON here, line by line, and it should. Why didn't you parse?
Don't you need curly braces?
Oh, yes, I forgot those. Thank you. All right, so JS, okay, so JS parsed for me into these values. Like I said, you probably won't be able to paste this, but you can type it or paste line by line, and that should process for you. So what a reparser will look like is this. And what I'm doing is I'm actually building this compound gate where each part knows how to access particular elements inside of what's going on. And so SO is a string parsing gate. AT is an array parsing gate, and it accepts a list of other gates to go within it. This is kind of weird. It's kind of messy. It allows you to be very precise about what you're trying to say. But the downside is that this JSON reparsing stuff ends up feeling like a domain-specific language inside of Hoon. Like it's a very particular kind of thing that we're going to do there. The other thing that's weird about this is every one of these is actually stored inside of another arm that ends up looking like that. So we're actually accessing the OT gate inside of DJS inside of format. The SO gate, the string processor gate inside of DJS inside of format. NI is going to mean number integer. And I could do other things with it to extract other kinds of values, but this is going to give me a number integer to do this. And so if I apply this reparser, it will just extract the values that I want directly. Since this is messy to write like this, we're going to introduce a new rune. So right now we haven't seen any new runes. We look at this, it looks a little weird, it looks a little odd, but we haven't seen any new runes. Let's actually try it as it is first. So let me write a gate called reparser. Reparser. All right, so there's that for you. And I should be able to reparser JS and just give me the values that I want. Yeah, so it gives me back a cell, which has, it's a 3 tuple of the name, the membership status, and the dues value that's associated with this string. So this is what a reparser is going to do. You're going to give it something that structurally matches the values that you're trying to get out of the JSON. And so what this will look like in practice is you will receive values from a web browser, from a client session as a JSON. And then you will plug them into this JSON, you'll parse and then you'll reparse, and you will get out on the other end something that looks like this. And this will be this nice clean thing. You'll be able to coerce it to a type like an update or an action or a datum or like whatever you want to call it. And you'll be able to work with that value directly. That's the goal of reparsing, is to give us this nice clean Hoon tuple, 3 tuple, 3 element cell that we can work with here. I said we're going to introduce a new rune. And so the other way that I would write this, the way that I would write this more conventionally would look like this. All right. TIS reparser ace, TISCOM gap DJS col format. And then senhep OT colsig, so forth. So what does TISCOM do? What does TISCOM do for me? If you compare those two ways of expressing the same thing. We're going to call this unwrapping the namespace. This is one way to put it. But basically,
Looks like a spread operator, sort of.
yeah, kind of. But it's the way that we're going to open up the names in a core, basically. Right. So DJS col format is a core that has all these arms inside of it that's somewhere in the standard library. And by TISCOM, all of the children of this rune now are able to look directly into DJS col format, and you don't need to specify the context anymore to see them. We don't use TISCOM very much, but we do like to use it when we have a lot of functions that are buried deep inside of some core that's farther out there. So it lets you resolve those by having those available to you. So you'll be able to write cleaner code by doing that. Now, there are other things, so I should be able to say something like, let's see, NI was the one that I just used for sen sig dot 123, gives me that value back. So if I do NE, okay, what did NE give me? What's a dot sig 123?
We saw that before, right?
Yeah. What was it before?
String.
No,
String.
sig dot was the string.
Oh, floating point.
Yeah, so this is a floating point value. Yeah, so that's a pat RD. That's NI, NE, NO should convert it to text. Let's just unwrap it as text. There's some others like NU. I think NU might need. NU is a hexadecimal one, and I think there's some trick to what it wants in terms of it's some sort of thing like that. It decodes a hexadecimal string. Anyway, there's a lot of them that are floating around out there. There are a lot of string ones, right? So we were talking about strings. So if I SA, then I get it as a tape. If I SD it, then it attempts to convert it to a pat DA, to a date value. SO will take it to a chord. SU, then anyway, there's a lot of these. Some of them are documented, some of them are not. There's different array functions. You can unwrap it to a list, you can unwrap it to a set. You can unwrap an object to a map, and so forth. There's a lot of these. And so you can poke around and look at the other examples that people have out there. There's also a gate, excuse me, there's a generator. Let me see if I can find the link to that and give that to you. There's a generator that is called John that Litlep Nibite wrote. Yeah. And John is a generator that you can give an example of a JSON, like this text inside of the quotes here, and it will attempt to produce a reparser that would return all those values to you. So you'll still need to take that and make decisions about like what kind of number am I getting back? Or, do I want the string back as a chord or a tape? But it's really good for just structurally giving you, here's my reparser. Here's the values that I'm looking at when I unpack these things that I've received in my agent. Okay, so it's a neat little tool. So that'll in the you got to see this stuff so like sort of what a reparser is doing, which is a little bit odd and weird, but you'll get used to it. And so it's also possible to wrap all of this inside of a mark file. So you can actually have a mark directly handle these things. So for instance, if I were, yeah, so one thing I could do here is if I know that anything I'm receiving from the web browser is a JSON, then I can add a JSON convert. This is to convert out, this is to convert from what I have. And then there's if I wanted to convert to from a receive a JSON and convert it to my local format, then I have like these frond and pairs, and these will sort of unpack. Oh no, sorry, I have that backwards. Action is I'm receiving a JSON, and then you can see here that I'm parsing a string, I'm parsing a value as a number, I'm parsing all this as an array, and so I'm returning an action back. And I can put this in my mark file, and now this will be automatically handled, and I don't have to do anything special in my agent. I can just use this if I were to write a web front end that interacted with Delta, which I believe we will do next time. If I recall correctly, I think Delta is the one that we write a front end for. And then this will, to send a JSON back is also kind of a weird domain specific language, but it's different. So a frond is a single value that's being pushed back out. I have to do things like scot my value to text to turn it into a string and so forth. And so this will allow me to convert my update type to a JSON and send this back out will be my goal with doing this. So next week we'll see how to connect this to the front end, and then all of my JSON to and from my browser, the language that my browser speaks, is automatically handled by these mark conversions, and I don't need to worry about it past that point, which is going to be pretty nice. Make it a little bit easier to deal with there. So yes, in terms of processing data, sending things back and forth, basically I'm either getting nouns, in which case I'm just sort of dealing with raw facts, and maybe I'm making an assertion and converting things, but I'm receiving a gift back and I'm making this conversion. Or I'm dealing with JSON, which is what a web browser speaks, and I'm converting to and from JSON to nouns to whatever my local type is. And that pretty much covers the common scenarios for this. If you wanted to talk to some other kind of entity, like you're using the lick vein and you want to talk to a serial port, for instance, then you might end up having to construct other kinds of handlers than these. But for apps where you're going to be either working exclusively in Urbit, like at the command line, things talking to each other, or you're going to be talking to a browser, this will cover most of the cases that you need to run into for both of those.